Live from the central coast of California, this is launch coverage of SWOT. You are looking at Launch Complex 4E at Vandenberg Space Force Base. We are just about 45 minutes away from liftoff of this Falcon 9 rocket for the International Surface Water and Ocean Topography mission, also known as SWOT. It's the first satellite mission to survey nearly all water on the Earth's surface. It will help researchers address some of the most pressing climate change questions of our time. Hello and welcome. I'm Raquel Villanueva with NASA Communications, and I'm joined by Nadia Vinogradova-Schiffer. Welcome, Nadia.
Good morning, Raquel.
Now, she is the director of the Ocean Physics Program at NASA's Science Mission Directorate in the Earth Science Division. Nadia, as a mission scientist, what do you feel most excited about on this very early morning?
Well, Raquel, we're launching SWOT, our next mission to track water on Earth's surface. It's been a long journey, 20 years to make us, to take us to the launch pad plus 1 day. And today, our water dreams are coming true.
And why is it important to track all of Earth's water?
Well, water is life. There are 8 billion people live on this planet, and we all depend on water to survive and prosper. We use water to drink, to grow our crops. We use water to produce energy and support our economy. Water is what controls our climate and weather. So essentially, SWOT will track all of this water for the same reason NASA follows water on other planets, because water is essential to life as we know it.
Absolutely essential. I have plenty more questions for you coming up, and we will be taking your questions throughout the broadcast. Send us your questions using the hashtag #TrackingWorldWater to learn more about the SWOT mission. And NASA is celebrating the completion of its historic Artemis 1 flight test. The launch from Kennedy Space Center last month was viewed by millions around the world. While in orbit around the moon, the uncrewed Orion spacecraft gave us these breathtaking pictures. Absolutely stunning, Nadia. Take a look at that detail.
Splashdown. From Tranquility Base to Taurus Littrow to the tranquil waters of the Pacific, the latest chapter of NASA's journey to the moon comes to a close. Orion back on Earth.
On Sunday, December 11th at 9:40 a.m. Pacific, Orion splashed down in the Pacific Ocean after a 26-day mission. The Artemis program will explore more of the moon than ever before and eventually land the first astronauts on Mars. Very exciting.
Very exciting indeed, Raquel. In fact, Artemis and climate change are two priorities for the agency. And you know, Earth and Moon are directly connected as celestial bodies. We're looking how climate change might impact this Earth-Moon system. So there might be more connection between SWOT and Artemis. So stay tuned.
Well, stay tuned for that connection. Now, let's introduce you to our team covering today's launch. Hundreds of people are gathered right now at our Hawk's Nest viewing area. That's where NASA's Jasmine Hopkins will talk with our experts. NASA's Megan Cruz and Denton Gibson will provide us with commentary from the Mission Director Center. Megan, NASA's Launch Services Program selected SpaceX to send SWOT into orbit.
Yeah, and so for the last couple of hours, we've been listening to both NASA and SpaceX teams as they prepare for launch today. And great news, both the vehicle and the spacecraft are healthy, the range is green, and the weather is looking excellent, 100% go for launch.
Yeah, absolutely. And and isn't always the case, but we have great weather for this.
Yeah, I love hearing 100%. This is the first time I've actually heard 100% for a launch, so that's exciting. And commentating with me today is Denton Gibson. He is a mission manager with NASA's Launch Services Program, and the perfect person to chat with me today because before your current role, you used to work with SpaceX really closely.
Yeah, for a long time, I was the Falcon 9 engineering team lead for the Launch Services Program. And I started working with the Falcon 9 when during our first mission with SpaceX. So that was many years ago.
Okay, many years ago. But a lot of experience you add today. Yeah. So the next big step for launch today is to start loading propellant into the rocket. Just a few minutes ago, the NASA team gave the go for propellant load, but now we have to do a SpaceX poll, right?
Right. And what the NASA poll is, the various groups within NASA making sure everybody's ready to go. We just heard that poll, everybody's good to go, and now the SpaceX team is going to confirm with the NASA team that we all ready to go.
Okay, perfect. Here's a live lookout at Launch Pad 4 East here at Vandenberg Space Force Base. We'll monitor the SpaceX poll that we just told you about, and then we'll check back in once fueling begins. Back to you, Raquel and Nadia.
Thank you. We have a fun way to interact with our launch broadcast right now. You can print out a SWOT bingo card. Nadia is holding one up here. It has different words on the card you'll hear while watching this show. To print one, just scan this QR code you see on your screen. We also have the website go.nasa.gov/SWOT-bingo. When you hear a word, mark it off, and when you get a bingo, share your win on social media with the hashtag #TrackingWorldWater. It's a good way to stay awake.
Yes, it's fun to play with kids during Christmas.
Exactly. Now let's go over the specs of the SWOT satellite. It weighs more than 4,800 pounds at launch. The satellite is just over 16 feet in height. Its solar panels extend to more than 48 feet in length, about the size of a tennis court. It will cover over 90% of Earth's surface at least once every 21 days. And SWOT will increase our tracking of lakes from a few thousand to over 1 million. The mission is set to run for the next 3 years. SWOT is a joint mission between NASA and the French space agency CNES. JPL shipped the payload to France in the summer of 2021. For more than a year, engineers worked at Thales Alenia Space to integrate and test the satellite. After a series of functional and environmental tests, it was ready for the trip from the Nice airport back to the US. In October, the satellite and its shipping container arrived at Vandenberg Space Force Base, where it was mated with the Falcon 9. Now, Nadia, this is a complex international partnership. Can you talk about some of the challenges the team faced?
Well, we actually gel very well with all our partners, CNES, Canada, and UK Space Agency. We're currently a large multinational science team spreading 6 continents. Quite a soccer team, just like a World Cup.
Exactly. And now you're all here today.
Yes, we are.
Well, water is fundamental for life. SWOT will help us understand where Earth's water is today, where it is coming from, and where it will be tomorrow. Take a look.
So for me, SWOT is water. SWOT is precision.
In one word, I would describe SWOT as beautiful.
SWOT stands for Surface, Water, and Ocean Topography. SWOT will be observing the elevation of water surface in the ocean, on the land. The water surface height will allow us to assess the water storage in lakes and stream flow of rivers.
Our water is one of our precious resources. SWOT is unique because it is the first global view of our ever-changing water supply on Earth.
SWOT's main instrument is called CARIN, which is the K-band radar interferometer. CARIN is what sets apart SWOT from other missions. It's a unique instrument that we're flying for the first time.
The CARIN instrument uses the 2 antennas, which are spread out on either side of the spacecraft, in order to bounce signals off of both of those to get a much larger view of the surface.
And being able to do it in very high resolution, higher accuracy, and also a wide swath so that we're able to measure large tracts over the Earth in a relatively small amount of time. SWOT is a pathfinder mission using new technology to address transformative questions on climate change and its impact on our environment.
We're collaborating with CNES, the French space agency, for these programs, but we're also helping the global community to be able to contribute and collaborate towards making our home planet a better place.
SWOT will make our models better, and our understanding the water budget helps us be able to steward that precious resource.
If water is out of balance, we could face droughts, and it could also lead to floods.
SWOT is going to be observing water in oceans, and ocean science is essential for understanding sea level rise and climate change.
Now we are facing a time that we need to be very precise. Therefore, we can accurately predict what will happen in our coastal cities 50 years from now.
Understanding that it is a finite source and we can't rely on that forever is something that's really important.
I'm just so excited and can't wait to see how it impacts the lives of others.
Without really understanding the Earth, we cannot protect it, because we know that the missions that we work on are going to have an impact on our children and our grandchildren.
NASA has a family of satellites in orbit right now, studying how the whole Earth works as a system. Karen St. Germain is NASA's director of the Earth Science Division. Thank you for joining us today, Karen.
It's great to be here.
And what kind of role will SWOT play in NASA's fleet of Earth-observing satellites?
Well, NASA has a fleet of 25 satellites today, missions that are looking down at Earth, at the atmosphere, at the land, at the ice, and the oceans. And these satellites tell us how the Earth works as a system. But SWOT, as we know, our planet is that we live on a water planet. And so SWOT will give us the first high-definition view of not just our oceans, but the inland waters as well. And and these waters play an important role in climate change and in everyday lives.
So it will be an exciting addition to the family.
Absolutely.
Now, what can we learn through space-based tools like satellites that we can't gather here on Earth?
Well, space is the ultimate high ground. It's a unique vantage point from which we can see the entire Earth. And that's especially important when we're looking at parts of the Earth that are remote, difficult for humans to get to. And I'll just give you one example. The southern oceans play an incredibly important role in our climate. They've absorbed more than the oceans in total have absorbed about a quarter of the carbon dioxide, the greenhouse gases that have been emitted in the industrial age. The southern oceans, because they're cold, play an incredibly important role. So set from the unique vantage point of space, we can see these remote areas and better understand how they play into the global system.
And Karen, just going forward, how do you see SWOT being a trailblazer for the next Earth science mission over the next decade?
It's a great question, and we are already hard at work building the next generation of Earth-observing satellites. And these will also look at all the aspects of the Earth system, but just as important as what we're doing is how we're doing it, with open science principles to try to accelerate the pace of discovery from these systems, and with partners around the world. So SWOT is in many ways blazing the trail for how we will develop that next generation of capabilities to accelerate discovery and the use of the data to inform decisions around the world.
And Karen, how are you feeling about today's launch?
I could not be more excited. We've been waiting for the SWOT launch, and as the team has gone through the challenges that you discussed a few moments ago, and so it's been a long road to get here, and we are so excited. We cannot wait.
Oh, it's very exciting. Thank you so much, Karen, for joining us.
Enjoy the lunch.
We all will. All right. Thank you so much.
Now, it is T-minus 32 minutes and counting to today's launch of the SWOT satellite. Let's check in on launch operations. Megan is live. Megan, preparations for this launch began hours ago. So where do we stand right now?
Yeah, so Falcon 9 fueling is underway. SpaceX's launch director gave the go for propellant loading about a couple of minutes ago. So now liquid oxygen and RP1, or rocket-grade kerosene, both are going in to the rocket's first stage.
Right, correctly. And it's underway, and everything is going smooth so far. No issues to report.
Perfect. So if we take a live look at the pad here, a beautiful shot of the payload fairing there with SWOT tucked safely inside. Denton, we talked about why SpaceX starts fueling so close to launch. Why when other launch providers start hours earlier?
Yeah, and one of the main reasons they're using densified propellants. So they're very, very cold. That way it allows them to fit more fuel and oxidizer into a tank without having to increase the size of the tank. And the reason why it's so close to launch is that you don't want those densified propellants to heat up any, and that will cause a lot of cause you to kind of bleed off some of your oxidizer, etc. So, and that's why they do it so close to launch. It doesn't give that fuel and those propellants much time to heat up.
And as we look at this live picture here, you can see that telltale sign of soot on the booster there. That means it's flown to space before.
Yes, this thing has flown 5 times before this, and it's a combination of Space Force missions as well as some commercial missions. So we do have some familiarity with this booster, and the soot is just a little seasoning on the booster.
Some seasoning. I love how you say that. Okay, well, perfect. So far, so good. A really quiet count. We're hearing the call-outs we're expecting. Nothing out of the ordinary. So, again, so far, so good. So we'll send it back to you guys, Raquel and Nadia.
Thanks for the update. We'll go back to our commentators as we get closer to launch in just a few minutes. But first, we have some questions to answer about the SWOT mission and water. Our first question is from a student. Here's Meadow.
Hi, my name is Meadow. I'm 7 years old and I live in Studio City, California. I wonder how much water is on planet Earth.
Hi, Meadow. Good question. There are more than billion cubic kilometers of water on Earth. A lot of water, Raquel.
It's a lot of water. Thanks for your question, Meadow. And we have a social media question coming up as well. Let's see it. At Kawan wants to know, what is the most important thing to know as a NASA scientist?
To know as a NASA scientist, well, hard work, some math and physics is a good skill, and have fun while doing it.
And you possess those all, Daria. We have another question coming up. Zeros and Math wants to know, what's the accuracy of SWOT?
We are shooting for centimetric precision with SWOT. It's a very precise mission. We are improving our accuracy about 10x compared to our current observing capability of the ocean water and inland waters as well.
All right, thank you. All right, we have one more question coming in. Kevin Rainville wants to know, will it give us the rate of sea level rise?
We will definitely observe the rising oceans and rising sea, particularly close to the coast. And as we collect more and more data, we can estimate the rate, which is, the change over a certain period. This is what the rate is. Yes, excellent question.
Yes, it was. Now, remember, you can send your questions online by using the hashtag #TrackingWorldWater. Now, you are looking live to the launch pad right now. We are T-minus 28 minutes to liftoff. SWOT data will help researchers better understand the ocean's role in climate change. Let's go to Jasmine live at the Hawk's Nest to learn more about the mission's science.
Thank you, Raquel, and welcome to the Hawk's Nest. This is the main viewing location at Vandenberg, and there are over 500 guests scheduled to be in the surrounding area tonight. And right now, I'm thrilled to be joined by Li Luangfu, the SWOT project scientist who's been working on water monitoring missions for over 2 decades. Welcome, Li.
Thank you very much, Jasmine.
Of course.
Pleasure to be here.
We're so glad to have you. It is very special. Can you tell me, what are the main science goals of SWOT?
Yeah, the main science goals are to better understand the ocean's role in climate change and how in a warming climate is affecting the Earth's rivers, lakes, and the reservoirs. So more than 90% of the heat since the Industrial Revolution, the global warming has been absorbed and stored in the deep sea. SWOT will provide a high-definition view of ocean topography for calculating ocean currents that transport the heat from the atmosphere to the deep sea. So the data will help improve ocean models to assess the ocean's capacity in the future to keep absorbing heat, protect humanity from global warming. And also in a warming climate, the water cycle of Earth is accelerating, making it very difficult to track and manage water resources, and also difficult to predict flood and droughts. So most of the lakes, rivers are not well sampled, but the SWOT for the first time will provide a global survey of the elevation of the lake storage of water and the flow rates of river, allow us to better model and so manage the water resources and predict floods and droughts. This is in a nutshell.
Right. From previous satellites.
Yeah, it's all about the spatial resolution and the coverage. For instance, the footprint of the radar on SWOT is 1,000 times smaller than conventional altimeter, making this spatial resolution of SWOT much, much higher. And also, it will cover all the ocean and the surface water without any gaps between 78 degrees north and south.
Wow. So we're getting something we've never seen before. And Lee, you've been working on SWOT since the beginning for 20 years. What does it feel like to be here for launch?
Yeah, this mission is 20 years in the making, and this is the fourth satellite mission. I serve as a project scientist. So, but this mission is the most complex and challenging, representing the culmination of my 40-plus years career at JPL working on oceanography from space. So my feeling now is a mixture of excitement, fulfillment, and also some anxiety.
Right, yes, a little bit of anxiety. I know that you and your team will breathe a sigh of relief when we're done tonight.
Absolutely.
Fantastic. Lee, thank you so much for joining us.
Yeah, thank you.
Of course. Raquel, back to you.
Thank you, Jasmine and Lee. The SWOT satellite is truly a remarkable spacecraft. Earlier, I got a chance to look at it up close with SWOT project manager Parag Vaze. Parag, we're standing here in front of a 1/3 scale model of SWOT. So can you tell us a little bit more about the key scientific instruments on board?
Absolutely. So on this model, of course, you see the full spacecraft, but the instrument package is really on this configuration, first featured with our brand new instrument called the CARIN, Ka-band radar interferometer. What makes it an interferometer is really having a radar with signals that are transmitted and received from two separate antennas that are separated by a large distance. We also need other instruments to make SWOT work. We have a radar altimeter, which is a more traditional kind of altimeter, gives us precise but very small strip maps. We have a microwave radiometer that's used to correct the altimeter measurement in terms of the water vapor as the signal is going through the Earth's atmosphere. And we also need a set of instrumentation that tells us a very accurate position of the spacecraft in space itself. We have a GPS receiver that you don't see here, it's inside. We have a DORIS system, and we have the laser retroreflector array.
And can you let us know how SWOT will communicate?
Data, first of all, 1 terabyte of science data every day that has to be downlinked and then processed into products. The key to being able to do that, of course, is we have a very large recorder, memory recorder inside the module here, but then getting it out is the job of this antenna system. That's the X-band antenna system that's downlinking at 600 megabit per second. And we also have an S-band system that's more for command and control and basic mission operations.
We obviously can't take a SWOT like this in space. How will it fold and unfold after launch?
So the whole system is, of course, needs to be compact. It's folded off to the side of the payload module that you see here, and it basically deploys in 3 phases. One that's first coming up, and then moving out, and then the antennas finally deploying on the side themselves, and then the whole system is locked in place.
It's a very interesting explanation. Thank you so much, Parag.
Of course, happy to do that.
Time to check in with the launch team at the Mission Director Center to see how the countdown is progressing. Megan and Denton, how are we looking?
So we are T-minus 21 minutes and 59 seconds and counting until liftoff, and fueling of the SpaceX Falcon 9 continues, right, Denton?
Yep, it's continuing, it's progressing just fine. Everything is moving along as it should.
Great news. So the U.S. Space Force, we know, is responsible for the range, making sure it's safe to fly our intended trajectory. Any concerns there?
No, actually. The range is green right now. Weather's looking good. All of the assets in the correct configuration. And so we're all completely green right now.
Talk to me about trajectories. That it's not an easy task to design one, right?
That's where a lot of the real rocket science is to design a trajectory. It's basically you're trying to get from the launch pad to a point in space. And along the way, there is some things you may encounter, the other orbiting satellites, some debris up there. So you have to make sure you avoid it. And the work that goes into it is very interesting because the team has a very detailed analytical model of how the launch vehicle will perform, and they marry that with everything that's orbiting the Earth and trying to understand which paths we can take, when we can launch, times, etc. I mean, there's a lot of work that goes into it, and that's where a lot of the real rocket science is done.
Yeah, and we're talking about years of work, right?
Yes. In some cases, it's over a period of years where you kind of develop in your trajectory for the spacecraft, and then also developing the trajectory for the launch vehicle. So it's a lot of work that goes into it.
Yeah, today's launch will be a huge moment for a lot of people who have worked their trajectory, who have worked on this spacecraft, who've worked on the vehicle.
Yeah.
It's many years of hard work.
Yes, it's been 20 years since some of the folks who've worked on the spacecraft has been working this mission. So I mean, it's going to be an exciting time for everybody.
And now here they can see again their spacecraft sitting in the payload fairing at the top of the Falcon 9 on the launch pad here at Vandenberg. The Space Force also monitors the weather for us. And again, let's take a look at the weather graphic we have prepared for you guys. The launch weather officer reporting 100% go for launch. Amazing.
Yes, it's very rare to see that, but we're happy to have it.
Absolutely. And speaking of seeing, it seems like we are going to see the launch today, right? Visibility is looking amazing. Not the typical fog we usually see here.
Yeah, it's usually foggy here, but we're in for a treat because we actually got some clear day today, so we can actually see the launch vehicle.
Yeah, and then here we see some of the venting we were talking about. We have to vent, right, to maintain the right kind of pressure.
That is correct. I mean, and you will see this as a normal part of it. You'll see it kind of cycling on and off throughout the count, just maintaining the appropriate pressure within the tanks.
And this is venting of liquid oxygen, right?
That is correct.
Okay. All right. So everything is looking good. Can't wait to see this launch as we were talking about. So we'll send it back to you, Raquel and Nadia.
All right, thank you so much, Megan and Denton. Joining us now on the West Coast is Janet Petro, the Center Director for Kennedy Space Center on the East Coast in Florida. Thank you for joining us today, Janet.
Thank you, Raquel. Happy to be here.
Great. Now, most launches take place at Kennedy, but sometimes, like today, we launch from Vandenberg. And why is that?
Yeah, so the Launch Services Program has multiple locations where they launch from. And so as you mentioned, we're here today on the California coast, and we have several locations in Florida, but also as far away as Alaska and New Zealand. It generally depends on the science mission itself, right? The science mission and ultimately the orbit that it needs to be in to conduct its science. So in general, we launch from the East Coast when we need an equatorial mission. And then in the case of today, where we're looking more at the polar missions, we generally launch out of the West Coast here at Vandenberg.
And tell us more about the Kennedy Space Center involvement in launches here at Vandenberg.
So the Kennedy Space Center, we are very, very proud to host the Launch Services Program. And we've been doing so since 1998. And that program, I'm very proud of that program. I tend to think of them as the world-renowned experts in launch vehicles, and they really, really do understand all of the launch vehicles and provide a great service to our agency. They really do the end-to-end services on launching a mission. They'll work with the spacecraft providers. They'll work on the design. They provide data, telemetry, and then today we're providing the launch services, the mission assurance for each of the missions. And like I said, they've been doing it since 1998. They do a really, really great job whatever location the mission is going out of. So very, very proud of that program, and we host them out of the Kennedy Space Center.
That's an excellent program, Janet. And what Earth-related missions are coming up for you in the near future?
Oh, goodness, I am so focused on this year. You know, we just had the JPSS-2 in Lofted, and now what we're doing today with SWOT. I'm trying to think next year. We have a little bit of a break until April coming up. We did earlier this year launch the GOES mission.
Right, some ISS launches.
Yeah, I can't, and you know, of course, the other missions outside of the Launch Services Program. Of course, we do the crew to the International Space Station. We do the cargo to the International Space Station, and you know, we just came from our big mission was Artemis, and very, very proud to get that launched out of our pad. And you know, we just recovered the vehicle down in San Diego, and that was an incredible experience. The Exploration Ground Systems program down at Kennedy, they're the ones responsible for the front end, the launch piece of that program, and then the recovery operation here on the West Coast, and they did a really outstanding job. We had a tremendously busy year at the Kennedy Space Center, and I like to say it's our diamond anniversary, our 60th anniversary. So it was a great way to really cap off the year with Artemis, and now ending with the SWOT program here tonight. We had a record number of launches. We're at like something like 53 launches that we supported from the East Coast, and our center supports whether it launches on our property, Kennedy Space Center property, or on the Space Force property, Cape Canaveral. We provide all kinds of services, whether it's our propellant services or standing up our EOC. And so if you think about that, 53 launches, that's about
a fantastic
one a week.
Year.
One a
Thank you, Janet, so much for that
you all.
Anniversary. Now, there is a growing community of scientists eager to use SWOT data. Let's go to Jasmine live at the Hawk's Nest to meet one of them.
Yes, Raquel, that is right. I'm here with somebody who is also eager to get his hands on that SWOT data. Toby Minear with the Series Group from CU Boulder in Colorado. Welcome, Toby.
Thank you. Glad to be here.
We are so glad to have you here. You are a research hydrologist with that group. So can you tell me, what are some of the applications of SWOT?
Well, SWOT is amazing because it has this really unique capability of measuring water levels over a big area. And so for people that are water managers in particular, there's a lot of excitement there because we really don't have this kind of capability at present. We have to do these things from the field, individual point measurements and things like that are very hard to make in the field. And so we have a lot of interest from people that are like municipal water agencies, state agencies for dam safety, federal agencies, all really interested in getting their hands on some water level data in particular and storage change. So be very exciting to see it.
It is very exciting, and really what I hear you saying is that SWOT is changing the game. So what are some of those specific applications, maybe agriculture or flood zones? How is it changing our lives in our own backyard?
Yeah, well, so a few things that it will change are, so for example, flood risk. We really don't have a good sense of where flooding occurs and when and why, so how much water requires flooding to occur. So for example, a good place for that is on the coast. We don't really have very many gauges along the coast at the freshwater and saltwater interface. And so, yeah, I think we'll see a lot of changes there, a lot of changes inland for lakes and wetlands too.
Wow, that's really exciting. And I understand, Toby, you're also in this group called the Early Adopters. What is that, and who's in that?
Yeah, so the Early Adopters group is about 25 different organizations. They come from all over the world. And these are people that are interested in SWOT data. They've heard sort of through the grapevine that there's some data coming out for water level data. And these are agencies that are non-governmental organizations. They're governmental organizations ranging from city level water agencies up to federal agencies. So a lot of excitement there from the water community.
Right, very exciting. Toby, thank you so much for joining us.
Thanks.
Raquel, back to you.
Thank you so much. This will be the last launch for NASA's Associate Administrator for the Science Mission Directorate, Thomas Zurbuchen. During Thomas's 6 years in the role, he has overseen nearly 100 science missions, including SWOT, DART, the Double Asteroid Redirection Test, the Mars 2020 mission, and the James Webb Telescope. He also co-authored and authored more than 200 articles and received many agency awards. Congratulations, Thomas.
Congratulations, Thomas. Yes, Thomas will be missed. He is known for his energy, dedication, and scientific curiosity. When I was doing my first launch with him, Sentinel-6, Mike Friley, he was very supportive. So yeah, Thomas will be missed. But congratulations, enjoy, well deserved.
Absolutely, enjoy that. The president of France's space agency, CNES, Philippe Baptiste, sent us this message about today's launch.
The result of NASA and CNES historic partnership in oceanography that all started more than 30 years ago with TOPEX Poseidon is really essential. And I am very proud to send you this message and to be with you, at least in spirit, for this launch. I want to say once again a few words how proud CNES and its team are to be involved in this ambitious international adventure alongside NASA. SWOT is the first space mission to survey the planet's freshwater resources on a global scale. The water elevation of lakes and water courses, the discharge of rivers, and the fine dynamics of the oceans are all vital data that are going to help us better adapt to climate change. In this respect, SWOT truly marks a revolution for space hydrology, and we are proud to be embarking on this endeavor with the French community of scientists, of users, and of course with our industry. I wish you a successful launch, and go SWOT, go!
Go SWOT! Climate change is a topic front and center for everyone, including NASA. Joining us now is NASA's Sandra Conley. Thank you for joining us, Sandra.
Thank you for having me.
Now, as a leader in science, what does it mean to be part of this mission?
Oh man, this is such an exciting mission. You know, it's unprecedented in many ways. It's going to be the mission that for the first time ever, we're measuring surface water around the world. Freshwater sources, saltwater sources, how they ebb and flow and move in between each other, how the energy is transferred across those water bodies, and also with the environment. And it's really going to help us improve our weather forecasting ability and our climate prediction abilities.
Real trailblazer. Now, SWOT is a joint mission between NASA and CNES. Climate change knows no boundaries, so why is it important for a mission to be an international collaboration?
So, science knows no boundaries, right? So our scientists are from all around the world, and this partnership with CNES is tremendously important. It spans over 30 years on ocean altimetry missions, and that's not even counting other partnerships that we have with CNES to achieve our science. So we're looking forward to many, many more missions together with them.
Well, Sandra, as you know, SWOT is the first science team that fully complies with open science requirement. Can you tell us more about NASA's open science paradigm and how do we kick off the year of open science with SWOT?
You know, that's a great question. So our space satellites give us a really unique vantage point to observe the Earth, right? So we're able to look at it as a global system, right? And the data that we've collected through our satellites over the 50 years allow us to really look at the ground, the atmosphere, and the oceans. And what open science and open data is going to enable us to do is to take that to the next level and give it to the individual user, whether they're decision makers at the local level, at the regional level, or even tribal communities. Is to give that information to people so that they can make informed decisions regardless of their business. You don't need to actually be a scientist or an engineer moving forward to be able to leverage this data and apply it to your day-to-day business.
Looking forward to the data. Thank you so much, Sandra.
Thank you.
Now, let's head over to our commentators. We are T-minus 7 minutes our launch of the Falcon 9 rocket from Vandenberg Space Force Base. Megan and Denton will navigate us through that terminal count.
Yeah, just under 8 minutes to liftoff, and we are looking fantastic for launch. Weather is a go. No collision concerns on the range for our instantaneous opportunity to launch at 3:46 and 47 seconds Pacific time. We see a live shot of the Falcon 9 sitting on Launch Pad 4 East here at Vandenberg Space Force Base. This reusable two-stage rocket standing about 230 feet tall. The first stage is the bottom two-thirds of what you see there. That's called the booster. And then at the right over that, you see this black piece there. That's the interstage adapter, which connects the first and second stage. And then at the very top, the payload fairing. And you see SWOT painted on there. SWOT is tucked safely inside of it, folded up to about the size of a mid-size car.
Engine chill.
And we just heard the call out for stage 1 engine shield, and basically what that is just the getting the engine ready for the flow of the colder temperatures. So it's kind of like if you imagine if you were to jump in a really cold pool and you know your muscles tense up and everything else, and we don't necessarily want that with the engine. So we slowly start to bleed in those liquid oxygen to kind of bring it down to the temperature that it'll be seeing during flight. So that's really what that is. It's really preserving the stress on the engines, and it's getting ready for flight.
Yeah, that was a great analogy.
So,
yeah, you made me cold thinking about it. So we see some of that liquid oxygen venting off now, both the first and second stages, right?
Yeah, and you're seeing that because the booster is very, very cold because that liquid oxygen is inside there. And soon you'll hear the call out for stage 1 RPO leaks. They're wrapping up fueling of the stage. Of the stage 1 right now, and so we should hear that call out here in a few seconds.
Stage 1 LOX load is complete.
And so SpaceX is also loading helium
Stage
gas
1 fuel load, correction.
into both stages, and will continue to top off until about a minute and a half before launch. Falcon 9 uses helium as a pressurant, meaning it uses helium to maintain pressure in the tanks as liquid oxygen and RP1 are consumed by the engines during ascent. The first stage has 9 Merlin engines, hence the name Falcon 9. The second stage has a single Merlin vacuum or MVAC engine, so you'll often hear references to MVAC throughout the count.
Yeah.
Next call out will come in just a couple of seconds. You'll hear that the spacecraft is on internal power and configured for a launch. That just means that the spacecraft is now running on batteries versus getting power from the strong back you see there.
Tanks are pressing for strong back retract.
And the strong back is getting ready to retract. The strong back is that mechanical structure you see just to the right of the vehicle. And they're just pressing up the tanks and getting ready for that. You'll see it tilt back slightly initially, and then when we get closer to launch, you will see it tilt about 45 degrees back, get out of the way so the Falcon 9 can clear the pad with no issues.
And that tilt starts when you see that cradle. It's kind of like a hug around just at the base of the payload fairing there. You'll see those arms start to open, and that will allow for the strong back to start tilting backwards.
Yes, that is correct. And you can see from the video, you can see that cradle's opening up, and then you'll see a few seconds after that's completed, the strong back will tilt back slightly.
And now we're going to pause for an upcoming poll here.
NLM on countdown 1. NLM copies.
NLM is the launch manager for this mission, NASA's launch manager for this mission. Again, we see that strong back retracting, and you see those connections between the strong back and the rocket. Those are umbilicals, and that's what continues to feed the rocket with liquid, electricity, gases, right up until launch, right?
That is correct. And what we're waiting to hear right now is just the SpaceX team confirming with the NASA launch manager that the team is ready to go. And so
LD, NLM, countdown 1. LD, go ahead. NASA is go for SWOT launch.
There you go. Perfect news.
Stage 1 LOX load complete. Stage 1 POGO.
Yep, and you heard the team is all good to go. And so right now, stage 1 LOX load is complete. At this point in time, the stage 1 is completely filled with fuel. We're just waiting for them to top off the stage 2 tank.
And today we're going to be treated to some sonic booms since the booster will land right back here at Vandenberg Space Force Base, just about 1,000 feet from where it's going to launch.
Yes, which is always exciting to see. I mean, it's just so fascinating that the booster is going to land basically just very close to where it took off from.
Yeah, that's going to be great. And as you said, again, because visibility is so great, we won't just see the launch. We're also going to see that booster coming back to land.
Yeah, and it's taking everything I have to stay inside and not go outside and see this with my own 2 eyes.
No, you have to sit in here with me. And in these last few minutes, Falcon 9 is performing final health checks on its primary communications, avionics, and propulsion systems in preparation for flight.
This is The Rock. Range is green.
And we just heard that call out that the range is good. And we should surely we should be hearing the call out for that stage 2 LOX load is complete. And then at that point, all of the propellants will be loaded onto the vehicle.
Stage 2 LOX load complete.
You just heard that call out. So all the propellants are done loading. And at this point in time, we're just gearing up for Falcon 9 to go into startup, which is basically the computer taking over and going through its last set of configurations and checks to make sure that we're good for launch leading into T0.
And remember how Denton was telling us earlier, you know, we see the amount of liquid oxygen coming off of the rocket fluctuating throughout the count. Here, that's what we're seeing again to maintain that pressure, the correct pressure in both stages.
Yep, and what you're seeing right now is them venting the LOX that was in the umbilical tower 9. So it's venting that out and getting it all ready to go for launch.
Falcon 9 is in startup.
And we just heard that call up. Falcon 9 is in startup, which means the flight computer is taking over and is just preparing for its initial launch sequence.
And now both stages are pressurizing for launch. Next call out in just a couple of seconds.
Launch director, go for launch.
SpaceX launch director confirming go for launch. Range remains go, weather is go. This launch will mark the 101st mission of NASA's Launch Services Program based at Kennedy Space Center.
15 seconds.
Here we go.
10.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition and liftoff. Liftoff of SWOT, our first global survey of Earth's surface water to study how this ever-changing resource affects our climate.
And there we get a nice view from the ground camera, and also we switch to the onboard camera.
Now, Denton, you didn't go outside to see the launch, but now we're feeling it inside here in the Mission Director Center, the rumble all around us from launch.
Absolutely. And now you're getting a good look at the onboard camera looking down towards the aft end of the rockets, and you can see the Merlin engines coming to life there.
And this room coming to life, really. Lots of rumble going on in here. And we're soon going to hear that the rocket is supersonic, meaning it's going faster than the speed of sound, followed by Falcon 9 reaching what's called max Q, the moment of peak mechanic stress on the rocket.
Yeah. Look, we getting nice views.
Falcon 9 is supersonic.
Yep, just heard a call out for supersonic. Getting a good shot of looking at the onboard cameras
Max
there.
Q.
We just stepped through max Q.
Next call-outs are going to come.
Engine chill.
And back engine chill, which means getting the second stage engine ready to start. And so which means we'll be coming up on stage separation shortly, followed by stage 2 ignition.
We see this beautiful shot of all of the Merlin engines, all 9 of them lit up.
That's what 1.7 million pounds of thrust look like.
Lots of thrust. So the next callouts are going to come in quick succession, so let me walk through them really quick. So at T+2 minutes and 15 seconds, we're going to have main engine cutoff. That's MECO, meaning the 9 Merlin engines on the first stage are going to shut down. And then a few seconds after that, stage 1 and 2 will separate. Stage 1 will do a flip, and do a boost back burn to orient itself back towards Earth for that landing here at the Space Force Base.
And there we get a good shot of looking at the interstage. Basically,
Nico.
the camera is looking up towards the second stage.
Separation confirmed.
And there you go.
Live video of stage 1 and 2 separating.
MVAC ignition.
And there's a good look at the
Stage
MVAC
one,
ignition the MVAC engine coming to life.
That's great. You are seeing the stage 1 booster do its flip. And now the engine bell of the MVAC engine lit up. This is a camera shot of stage 1 here, again on its way back to Earth. In just a couple of seconds, we're going to see the payload fairing jettison.
Fairing separation confirmed.
We just heard a call out for fairing separation, and there's a good onboard view of the SWOT spacecraft, and you can see the fairing is gone at this point in time.
Another camera shot here of the engine on the second stage continuing to carry SWOT to its intended target. We have a couple of camera views of this engine here, so you might see a couple of
Stage
different
1
angles.
boost shut down.
Yeah, and then you'll see it cycling through the views of the stage 2 engine, and as we get closer to the separation, it'll go back towards the spacecraft.
And we just heard a call out for the boost back burn ending on stage
Both
1.
stages are on nominal trajectories.
And that call out was just to say both stage 1 and stage 2 doing what they were expecting them to do.
And we're hoping to get a video of stage 1 landing. So sometimes we don't always get it because of it's coming in so fast, and sometimes it's hard to capture it. So occasionally, sometimes we don't get it all the way, but we're hoping to get a good video this time.
T plus 4 minutes and 10 seconds into the launch of SWOT, and we've had a nominal ascent so far, no issues to report. Again, this is a video of a live shot of the engine on stage 2. SWOT stands for Surface, Water, and Ocean Topography, and this will be the first mission to provide high-definition data on more than 90% of the water on our planet's surface. It's a joint mission between NASA and CNES, France's space agency, with contributions from both the Canadian and UK space agencies. SWOT is the 4th NASA LSP science mission to launch from Vandenberg Space Force Base, and the 6th LSP science mission overall to launch on a Falcon 9, Denton.
Yes, and we got a lot more missions coming up on the Falcon.
Yeah, to see the partnership really grow for you too. I mean, again,
Yeah.
you really worked from SpaceX from the beginning.
Yeah, absolutely, and seeing their evolution over the years has been amazing to watch.
So coming up, we're going to see the booster begin its entry burn soon, and again, that entry burn is to slow it down as it approaches Earth for the landing here back at the base, instead of a drone ship.
Yeah, I mean, it's awesome to see it come back to land. And as I mentioned before, seeing it landing right very close to where it took off from is awesome.
So then how does this work? So again, we're going to have the entry burn that slows it down, and then there's a landing burn, right?
Yeah, so you have the boost back burn that kind of gets it back towards the launch pad, and then the entry burn kind of slows it down as it's coming into the atmosphere, and then you have the landing burn that basically puts it down gently on the pad.
Mm-hmm. Yeah, SpaceX has become real pros at landing their boosters.
Absolutely. And it's becoming routine for them at this point in time, and so this is just a normal course of business for them.
Again, we are looking live at stage 2.
Stage 1 entry burn.
And we just heard the call out for stage 1 entry burn. Means it's coming back into the Earth's atmosphere. And there we go. We got a good video of it.
Yeah, so you can see those hypersonic grid fins illuminated by the flame from the
Entry
booster.
burn
Stage 1 FTS is safe.
You see that the screen went black there. That's because they just
The
shut down the engine.
That's correct.
Both stages are
As
on nominal
planned.
trajectories.
But I was talking about those hypersonic grid fins that you see. Those help guide the Falcon 9 booster back down towards Earth. So now that we're done with the entry burn, the next burn is the landing burn.
Mm-hmm.
It's just one engine right just before it touches down.
Correctly. Just gently set it down on the pad.
The next milestone for the second stage is going to
Stage 1
be
is transonic.
SECO 1.
Yeah, and SECO 1 is the first shutdown of the second stage engine. And then for this mission, we're going to have 2 burns. So you'll
Stage
see
1 landing ready.
after stage 2 shuts down, it'll coast for a while. And then we got a good video of stage 1.
It's about to land. How exciting.
Coming in for its landing burn there.
Again, the grid fins moving ever so slightly to make sure that it's coming down exactly how they want it to come down.
Yep, and you could see the pad coming into view.
There it is. Wow, those sonic
and
booms.
Then the sonic booms. Trademark sonic booms.
Wow.
And good touchdown of the stage 1
touchdown. Booster. Perfect.
Stage 1 landing is confirmed.
So glad to see that live video. Again, sometimes we don't get it. That was amazing to see and feel, really.
Yes, see and feel, and we get to use this booster again.
Yeah. Again, this is the 6th flight of this booster.
That is right.
Okay, so we are still awaiting, again, that shutdown
Stage 2 FTS is saved.
Of the second, second stage. Yes. And when it does shut down, it's going to be over the Pacific Ocean, just west of the southern tip of Baja California. Again, exactly where we want it to be, following that well thought out planned trajectory.
Yep, and the team is reporting back. Everything's looking nominal. Stage 2, it's right where it's supposed to be, and looking good.
MVAC shutdown.
And we should see MVAC shutdown coming up here shortly. And there we go.
Yep, SECA 1.
Nominal parking orbit.
Confirmed. That's the trajectory you're seeing. It's flying south from where it just launched, and it'll continue to fly south down towards Antarctica. And so again, everything going as expected so far. The second stage is now going to coast for about 30 minutes. You can see that it is shut down there from that view. And this is a view of the spacecraft. Again, because the payload fairing has been jettisoned, you see SWOT right there on your screen. Exposed now that we don't need the payload fairing to safely get it out of the atmosphere.
Yeah, correct. And once the whole purpose of the fairing is to protect it while the vehicle is flying through the atmosphere at supersonic speeds. And then once you get up out of the atmosphere, there's nothing to harm the spacecraft, so you can jettison that extra weight and give your vehicle a lot more performance once you get rid of that extra weight.
Okay. The engine not glowing orange as it had before because, again, it is shut off, so it will coast for about 30 minutes with SWOT attached to it before some maneuvers are needed to keep it on the right trajectory, again, to get it in the orbit that we want it in. So Denton and I are going to be back then with you to walk you through those operations, but for now, we're going to send it back to Raquel and Nadia, who I'm sure are very excited to talk about how the experience launched today.
Whew, that is right, Megan and Denton. Just 10 minutes ago, we watched a spectacular launch from Vandenberg here in California. Nadia, describe what was going through your mind at that time.
What a spectacular, truly spectacular launch. It was a very bright splash on the sky, and a very loud one too. What an entrance. Welcome to the era of SWOT. Very excited.
I had some cheering going on here at the desk.
Yes, and the car went off, yes.
Yeah, we had car alarms going off. It was really exciting here for our view. Now, soon the SWOT satellite on board will separate from the spacecraft. SWOT stands for Surface, Water, and Ocean Topography. The satellite will survey nearly all the water on Earth's surface in unprecedented detail. SWOT will provide insights into how the ocean influences climate change, how a warming world affects lakes and rivers, and how communities can better prepare for disasters like floods. And we are covering every angle of the SWOT mission, from the new data the satellite will provide to how it is paving the way for future NASA Earth missions. Now, SWOT is a culmination of work by a global team of engineers, scientists, and technicians committed to improving our understanding of Earth. Let's get to know some of the people behind the mission.
Planning for future generations requires us understanding how much water we have.
And we need to understand the water cycle in a lot of detail, and SWOT will provide that for us. My name is Tahani Amar.
I'm Cedric David.
Mark Simard.
Christine Jabara, and I'm an integration test engineer at JPL.
I study the world's rivers.
I'm one of the principal investigators for SWOT.
SWOT is an Earth orbiting satellite. It stands for Surface Water Ocean Topography.
SWOT will for the first time make measurement of water surface elevation, not only on the ocean, but also on the lakes and rivers of the entire globe.
This in itself will be a scientific revolution.
Collaborations and relationship build bridges, and SWOT will be that bridge across the world.
SWOT is being designed jointly by NASA and the French Space Agency, with help from Canada and the UK. I was born in France, so SWOT is a match made in heaven for me.
Coming to work every day, it's always really nice to know that the system that we're building will collect science data that will help people.
I think finally I found a meaning to all of my research.
I believe SWOT will create a lot of peace because we all need water.
Now more than ever, it's important to recognize that water connects us all, and it might be the one thing that unites us all.
You really see how hard your team has worked there.
Yeah, we have a great team. You know, we gel really well together. We scientists, we dream, and engineers make our science fiction dreams come true. And then collectively, we make this NASA magic that enables discoveries and for the good of humanity and science.
It's magic indeed. We want to show you how some of SWOT's technology works, but to do that, Nadia and I had to go tap into our athletic skills for this one. Take a look. All right, Nadia, in order to learn more about SWOT, we have to play a little basketball.
That's right, Raquel. We're trying to explain how the heart of the SWOT mission works, which is a new instrument, a radar interferometer, which we lovingly call Karen. So Karen has two antennas separated by a 10-meter boom. One of the antenna transmits a signal that bounces back from the Earth's surface and received by two antennas with a little bit delay and out of sync. Now, Karen uses this information to compute the distance between the satellite and the Earth's surface, and they calculate the water height. So let's see how we explain it with the basketball. Okay. If you don't mind standing there, feet away from me.
All right, is right here pretty good?
This is perfect.
Okay.
And we will bounce the ball just like a SWOT satellite bounces a radar pulse between two antennas.
Okay. Yep. So what are we seeing here right now?
We're seeing how the ball, which is our radar beam, bounces over the Earth's surface, and by knowing the range, the distance, and we compute the height of the water surface.
So the ocean isn't a flat surface, there's waves. Like, how do you calculate that?
That's right. Let's bring a box.
Okay.
So did you notice when the water is a little bit higher that the ball returns to the antenna, to us, a little bit faster? That's how we know that we're retrieving topography, just like in the name of the mission. A satellite is doing thousands of bounces per second to capture the data on both sides from both antennas over a wide strip on the ground, about 30 miles, 50 kilometers wide. And then once we do enough of those stripes, we'll eventually cover the whole globe.
Nadia, I could really hear your excitement and passion for SWOT in that package. Why are you so excited for this new technology?
Yeah, it's a really pivotal moment, I think, for our space science industry as we are testing new technology with SWOT. This is our first in-flight demonstration for the SAR interferometer, and this opens a new way of observing Earth water height. So yes, it is a pivotal moment, and I'm very excited about it.
Yes, and like you mentioned before, the scientific heart of SWOT satellite is the Ka-band radar interferometer, or Karen, and it measures the height of water on Earth. Jasmine is live at the Hawk's Nest to learn more about how the technology was built.
That is right, Raquel. We're back at the Hawk's Nest, now joined by Eva Peral, the lead systems engineer for the Karen instrument on SWOT. Welcome, Eva.
Hi.
We are so glad to have you here. That launch just lit up the sky. What did you think?
Oh, it was impressive, really impressive.
It really was. It was beautiful. So you work on the Karen instrument. Can you tell me what sets that apart from other instruments?
Yeah, so Karen is a radar, and NASA has launched radars before to study the ocean from space. But Karen is a very special type of radar. It's a radar interferometer. That means that the signal that bounces off the Earth is received simultaneously by two antennas. These two antennas are separated by a long distance, about half the size of a tennis court, and they have to be positioned very precisely to levels that are like micrometers. So we're talking about the width of a hair. So you can imagine that adds a lot of complexity to the SWOT mission, but it is that technology that enables the resolution and the accuracy that we're expected to achieve with SWOT of the Earth's water.
Right, so we're seeing things in a precision that we've never had before, which is very exciting and complex. So were there any challenges that your team faced while creating Karen?
Yes, Karen has been pushing the envelope in many, many different fronts. I can give you many examples. One, I just told you before about the mechanical precision that we need to have positioning these two antennas. We also have a very high power amplifier. We need an enormous amount of power to be able to get that signal back to the satellite from the Earth at a level that is detectable by the radar. And that level of power at our frequency from space is by itself a technological achievement. We also have the radar produces a massive amount of data. In fact, over 60 terabytes of data every single day. And that's a lot of hard drives, as you can imagine. So we really need to reduce that data volume so that it's manageable and we can downlink it to the ground. And for that, we're doing some fairly unique signal processing in the radar in space. So all of those are really achievements. Karen is a unique instrument and one of a kind.
Right, it really is. You and your team should be very happy with this achievement. And Ava, you yourself have been working on this for a decade. How does it feel? You know, I know those last few weeks can be like a race to the finish line. What is it like that you just saw this launch?
Well, for me, it's been my project since I started at JPL. It's been actually over 13 years. So this is really a very exciting moment for me. And myself and my team have been actually working very hard on what's coming ahead of us. Now that we're going to be getting the data from space, we need to make sure that the data is valid. It has the accuracy that we're expecting, and that's going to be a very difficult and critical task by itself.
Right, but this is just the beginning. Ava, thank you so much for joining us.
Thank you.
Raquel, back to you.
Thank you, Jasmine and Ava. Let's get to some questions for you, Nadia. Our first question is from a young space fan, Mark Andreas.
Hello NASA, my name is Mark Andreas. How we can see water from space?
Well, hi Mark. NASA can see different aspects of water from space. We could see how hot is the water, how the temperature, the surface temperature of the water is, how salty is our water, salinity of ocean salinity. We can see how heavy the mass of water, its gravity. We can see the volume or the height of water with satellites like SWOT, for example. We could see liquid water, frozen water, like sea ice. We can even see some content of water in the atmosphere. So we can see different aspects of water from space. Good question.
Yes, so many different ways to see water. And we also have some social media questions coming in. We have, how many times per day will SWOT orbit the Earth?
So on average, SWOT's nominal orbit is 21 a day repeat orbit.
Right. And we have another one coming in for you now. Let's see, how accurate is the equipment when measuring the current sea level from space? Meters, centimeters, millimeters, nanometers? We're really getting into that.
We're targeting centimetric accuracy of sea level measurements from space, which is a truly breakthrough. It's a 10x improvement of what we are currently doing. Yes.
Now you're doing such a good job answering these questions. We have another one coming in for you. What is ocean topography, and how does it work with SWOT?
Well, think of it, ocean topography, just like mountains and valley. Like I was driving here from LAX to Lompoc, just like mountains and valleys on the ground, you see hills and dips on the ocean surface. So think of it as well.
Great explanation. We have another question for you too. Let's get to this one. Will you be able to tell how clean the water is?
So we will be able to make some interpretation of water quality and its chemical composition, but we're mostly focusing on the volume, storage, and the height of the water with SWOT.
All right, let's see if we have another one for you. Will SWOT data help in predicting flash flooding more effectively than current technology?
We are with the rising sea levels, we do see more frequent inundations, including those related to flash flooding or sunny days flooding. And SWOT will continue the legacy of prediction of flood events related to the rising oceans.
We have one more social question for you to get to. Will this technology also help determine how much drinkable water is currently available?
Yes, we are targeting fresh water and our reservoirs in lakes and other reservoirs. The storage, the change in their volume and extent. Yes, drinking and available water for usage.
Wow, you just offered some great insight to SWOT. Thank you, Nadia. Now, before SWOT data, researchers could only collect information on a few thousand rivers and lakes, but with SWOT, it will be more than 1 million. Here is a look at how that kind of data can have a huge impact on people's daily lives.
SWOT is the Surface Water and Ocean Topography satellite. It's an international satellite that's going to give us this complete view of the surface water here on Earth, what's happening in the lakes, reservoirs, rivers, and also in the ocean. It'll tell us about how sea level is rising along coastlines and in the open ocean, and really give us a good understanding of how surface water is moving about the Earth.
Our goal is to provide data, forecasts, watches, and warnings at some key locations like the Willamette River in Portland, which is a major U.S. city that historically has seen some catastrophic floods. The better quality of the data that we have that feeds into our models, the better the forecasts are going to be, the more time that people will have to protect themselves and their property and ultimately our communities. A tool like SWOT is going to help us with making these really difficult projections and predictions for the future.
This is one of many reservoirs here in the Willamette Valley in Oregon. It is a human-made lake. It is a reservoir operated by the Army Corps of Engineers. The water managers here, they use weather prediction, they use hydrologic models, and the hope is that data like SWOT might be incorporated into those predictions to help them better understand this water body's filling and we don't want to overtop the dams, might want to start letting water out really quickly. They have to make a lot of complicated decisions. When you get a big storm event, we want to keep the community safe in the best way that we can. So how do we best manage operation of these reservoirs in terms of putting water out downstream to prevent flooding at a larger scale?
In lots of states, there are, hundreds, thousands of reservoirs, and many of those reservoirs don't have automated gauging available. And so these agencies have to kind of estimate how much water is in them and how that's changing. And with SWOT, they can just monitor that directly from space.
For us in Alaska, we have many, many rivers, and only a few of them are measured, or as we say, gauged. If we have data on when flooding is occurring or might occur, we can get crews out there to look at the bridge to make sure that the bridge and the associated roadway are still safe. If we can start collecting data on all rivers above a certain size remotely through satellites, it really opens up the amount of rivers that we can help understand what happens when they flood or how they flood. And that really improves our ability to manage our infrastructure and to design new infrastructure. That is where SWOT will really make a big difference.
One of the partners we're working with is the Department of Defense, and they're trying to fill gaps in the data that they have along the coastlines. Our military is obviously very concerned about what's happening on global scales, and they have installations across the globe. So SWOT will potentially provide an opportunity to fill in some of those gaps, allow them to make the impact assessments that they need for sea level rise in their facilities. So trying to understand and give them the information they need to plan for and then potentially adapt to these changes is really critically important.
Coastal wetlands like the Mississippi River Delta are extremely important because it acts as a buffer between us and the threatening ocean. with SWOT, because of its high spatial resolution, we'll be able to resolve water surface elevation right at the coast. So this is quite important because as sea level rises, the ocean will migrate into the land, bringing more salt into the land. So it threatens the infrastructure, the biodiversity in the wetlands along the coast. Hopefully, the types of models that we're producing can support how they decide to manage the river delta. And SWOT on its own will allow us to upscale these types of studies to the world.
I'm really excited about the new information we'll get from SWOT and how we can start to couple it to some of the needs that we see, both at the coastal interface and also on land. I think we can potentially see some immediate impact once SWOT's launched in these communities.
SWOT is an international collaborative effort not only between NASA and CNES, but with contributions from the Canadian Space Agency and the UK Space Agency. We'll hear from the UK Space Agency in a moment, but joining us now is Taryn Tomlinson with the Canadian Space Agency. Thank you for joining us today.
Thanks for having me.
Good morning.
Now, why did your agency choose to be involved with the SWOT mission?
Well, contributing to the first ever satellite to survey most of the water on the planet is truly an exceptional opportunity for us. Water is such an important resource and it is in so many ways linked with climate change. And we're so happy to work with our international partners again on solving issues that matter to all of us. SWOT is particularly important to Canada. We have the longest shoreline on the planet and we have over 1 million lakes, and it's so important to monitor the change of those lakes over time. SWOT is really going to benefit Canadians for strategic water management, but it will support humanity in the face of climate change.
It really is an international effort, as we say.
Truly.
Can you talk a little bit more about CSA's contributions to the mission?
I'd love to. CSA will be contributing a key component to the CARIN instrument. They're called the Extended Interaction Klystrons, built by CPI Canada. It's the high-powered amplifier that will help those Ka-band precision measurements for measuring the surface water. And so in addition to the device that we are contributing, we have science researchers who've been involved with the SWOT science team, and they've been developing the objectives, and they're also working to deploy instruments to key sites across Canada.
Yes, Taryn, we enjoy working with Canadian scientists. And speaking of that, what is the Canadian scientists as users are most exciting to use SWOT data for?
For the data, so we have some services, key services in Canada that we'd really like to improve. And so, as I was mentioning, that shoreline, navigation services to Canadians is going to be very important. Weather forecasting is going to be very important as well. As well as just to monitor, as I mentioned, the lakes and make sure that we keep our eye on the lake measurements. Our researchers are looking towards the north in helping northern communities as well. And so we're talking about clean water supply. We're talking about water management for the coastlines, for tides, and for estuaries, and also hydroelectricity. And I do want to mention, I'm so excited to see what Canadians will do with open science and open data.
Excellent.
Lots of data ahead, and I want to know, what was launch like for you today?
Well, it was exhilarating, and we had cheers and excitement outside. We were all outdoors, but what was specifically exciting for me was to see the return of the booster and that double sonic boom, and everybody jumped out of their skin. It was exhilarating. What a morning. Thank you so much. We're grateful to be here.
Absolutely. Thank you for joining us today. Very morning. Now, Beth Greenaway with the UK agency wasn't able to be on set with us, but she left this message.
The UK Space Agency has contributed to SWOT by enabling both our industry and our scientists to be part of the mission. We were approached by the French Space Agency, CNES, who are building the instrument for the mission. They needed a very complex bit of kit built in the UK, which essentially signals or moves the radar pulses around the instrument. And it was Honeywell in the UK that built this. In the UK, we're really fortunate to have some of the world-leading scientists who understand both the oceanography, how the ocean moves, and how satellites satellites can be used to measure that. It's really exciting to be part of such a big, exciting mission. It takes a long, long time to come through to a launch in 2022. To be part of that journey on the policy side, enabling people to really do the best of British engineering and the best of British science, to be part of such a huge global water survey that's so important for climate change and is really going to make a difference to what we understand about our world.
All right, SWOT will measure the Earth's water on a global weather. It will take into account how much fresh water flows in and out of lakes, rivers, and back into the ocean. It will also look at shifts in sea level. Nadia, you have a demonstration that illustrates the importance of our water that involves a gallon of water right here.
That's right. We wanted to look a little bit of the water storage, water budget, water cycle, and we imagine that all the water on Earth represented in this gallon of clean water. And how the water moves. So ocean is the ultimate source of all our water. Land does not produce its own water. All the water and moisture on land comes either directly from the ocean or it's subsequently recycled from it. And so some of it get back to the ocean, but some of it makes its way on land. Some of it is stored in the atmosphere. So if you just do a half a drop of your magic liquid, that would be representative of how much water is contained in our atmosphere. So not too much, right?
Yeah,
right.
Just a little bit.
So yes, and then about a tablespoon of that magic liquid, and I'll let you do the math in terms of how many. That much would be representative of how much available fresh water we have on land. So about 0.5% only. So also not that much. You know, most of it is contained in our salty ocean. So we humans, an ecosystem, we depend on this steady supply of water and moisture from ocean to land. And if the ocean supply is interrupted, we have droughts or even fires like you guys have in California that you experience perhaps yourself. Or if the ocean supply of water is too much, we get floods and inundation, just like people like us on the East Coast. So this movement and the supply-demand chain in this completeness would be seen by SWOT, just like you and I seeing it in this gallon.
Yeah, and what if too much water comes back into the ocean, as you were kind of describing?
Yeah, well, then the ocean becomes higher. The volume of the ocean rises, yeah.
And how much would it rise?
Well, currently we're observing about 3.4 millimeter of global mean sea level rise. I don't know if that makes sense. So in gallons, that would be about 300 trillion of gallons a year. That's how much water we add every year into the ocean.
Okay, that is a giant number. How can you help put that to
Visualize?
scale?
Well,
yes.
I mean, I guess if you line up all these jars, you would cover the distance from Sun to Pluto and back. So yeah, it's a lot of water.
The Sun to Pluto and back.
Yes,
a lot of water.
That's a lot of
water.
water.
Well, thank you so much, Nadia, for this. Now, a SWOT technology tracks changes in water volume over time, like you mentioned, and we will get a better understanding of Earth's water cycle. That data can be used to help prepare communities for rising seas and changing coastlines. Let's learn more about Earth's water.
Earth has about 370 quintillion gallons of water. If all that water was inside a single drop, it'd be 860 miles wide. Of course, it's not. Earth's water can be found all over the planet. Earth's water budget tells us where that water is and what form it takes. NASA has a fleet of satellites studying the location and movement of Earth's water, each designed to measure certain types of water. Some measure the movement of groundwater or ocean currents, while new missions like SWOT and NISAR will also fill gaps in our knowledge by measuring fresh water and possible hazards. Together, these missions help bring NASA's water budget and cycle into focus. So next time you feel a drop of rain on your face, imagine all the places that water might have been during the last few billion years and where it might be in the next.
You know, that video really shows off NASA's family fleet, doesn't it?
That's right, yes.
Yes, and let's jump back into questions from kids and social media. And, you know, speaking of family, looks like we have a special surprise for you, Nadia.
Ooh, okay.
Hi, NASA. My name is Kira. I'm 8 years old. I live in Washington, D.C. I heard that sea levels are rising. What I want to know is if me and all puppies are safe. Kira, out.
Who did we just see there, Nadia?
Well, hi, Kira. Yeah, this is Kira, my daughter. So I hope that you parents will keep you safe and your puppies as well. But when you grow up by 2050, I think sea level, I believe, would be about 0.5 meter high in Washington, D.C., which is about 20 inches of extra water where you live. And so that would be your job to keep your puppies safe. And actually, Raquel, NASA has a very useful tool where we could demonstrate and predict sea level rise 10, 20, 50, even 100 years from now. Not just for here in Washington, D.C., but all major coastal city all over the globe. And I see that we have, yes, well done, NASA, sealevel.nasa.gov, very, very effective. Yeah, we have a link.
sealevel.nasa.gov. And we have some social questions coming in for you as well. Let's see the first one coming up here. Oh, actually, we have a photo. This one is a picture. We have a space fan. Let's take a look at Watson. Oh, look at little Watson there.
So cute.
His mom, Lucy, says he has been a fan since birth.
Oh, wow, it's not far along, right?
Great, that is a very cute
Very
picture.
cute.
Now we have a social question to get to for you.
Okay.
Let's see. The first one coming up is, can you shortly describe the collaboration between CNES and NASA on the SWOT mission? Who does what?
Who does what? So NASA and CNES have been long-standing partners, working with CNES for more than 30 years, especially for satellite altimetry. This has been the relationship that we've been doing very strongly, going on into fourth decade. And when we talk about collaboration, it was a truly collaborative effort when we were doing both testing and engineering and ping-ponging our SWOT observatory back between JPL and Thales in France multiple times. So both agencies contributed major hardware instrumentation for the observatory.
And the questions just keep coming in. We have another social question for you to answer. Let's take a look. This one is, how long will SWOT be in space?
A good question. So the nominal mission timeline is 3 years. So we give our engineers a reasonable timeline to fulfill engineering objectives. But longer than that would be a very welcome bonus for our scientists to use SWOT data beyond those 3 years.
That's a great bonus. Let's get to the next social question. How is the data shared? Which institutions are the intermediaries and which are the end users? I will soon be working with the French government to study a link between water management and spatial infrastructure. It's an exciting subject.
Well, thank you. We think so too. So this is free for all. All data would be available to the public through NASA and CNES data providers. And not just that, we're actually welcoming a community to help NASA and CNES validate the data prior to the delivery of a fully validated data set. This is the experiment that Sandra mentioned that we're going through at NASA. It's called Open Science, and we are delivering and sharing pre-validated data sets with the science community. So all hands on deck. If you want to be a hydrologist or work with infrastructure as this person who asked this question, welcome.
Yes, data for all. Thank you so much, Nadia. We still have time to get your questions answered. Simply post your question online with the hashtag #TrackingWorldWater. Now, we are just over 41 minutes since launch. Commentators Megan Cruz and Denton Gibson are tracking the next milestones on this mission.
Yeah, hello again, guys, from inside the Mission Director Center here at Vandenberg Space Force Base in Central California. We're actually sitting right next to where Nadia and Raquel are, because this is where we can listen in to the teams who are still working the launch. So it's been about 41 minutes since liftoff from Vandenberg Space Force Base. We had a nominal ascent, and now we are looking at live video of the second stage. And the engine there not burning red hot anymore because it's been coasting now, right, for about 30 minutes, Denton?
Yeah, and what's happening right now is they're chilling down the engine. As we talked about earlier, they're just cooling down the engine, getting it ready to take on those, those densified propellants, which is down in the neighborhood of minus 300 degrees. So you see what's happening right now. It's just chilling the engine down and getting ready for second engine start, which is basically, it's going to be a very short burn that's coming up. And this burn is essentially just kind of doing a final orbit adjustment before getting into spacecraft separation. So that's what's happening right now, and we should hear the stage 2 engine restart coming up here in about a minute or so.
And so we just saw a map there. That's a trajectory. It's showing where stage 2 is. And right now it is just south of South Africa along the coast of Antarctica. So it traveled pretty far in just those 30 minutes.
And as soon as we get in range of the next ground station, the engine will start up again. And then shortly after that, spacecraft separation will occur.
And what ground station are we trying to hit?
So the ground station that we're kind of targeting right now is Hartebeestok, which is on the south end of the African continent in South Africa. So that's the ground station we want to get in range to kind of capture that spacecraft separation.
And so again, we need this burn to get it to.
Yep.
All right, and we see the engine lighting now. Again, the second burn of the second stage of Falcon 9, still carrying SWOT.
It'll be a very short burn. And we already have
nominal deploy orbit.
Engine shutdown. And we just heard a call out that we are in the nominal orbit, so which means we are kind of on the correct path to go to spacecraft separation.
I do just love that we see all this live video, and we expect to get some live video of spacecraft separation again in just less than 10 minutes. So you want to stick around for that, but for now we're going to send it back to Nadia and Raquel.
Thank you, Megan and Denton. NASA's Jet Propulsion Laboratory led the U.S. portion of this international mission. JPL's director, Lori Leshin, joins us now. Welcome, Lori.
Thank you.
Welcome.
Thank you both. What a fabulous job you're doing.
Thank you. Well, this is your first launch as the director for JPL.
Yes.
How excited are you for this mission?
Oh, I'm thrilled. I mean, first of all, it's just been an extraordinary day here, getting to be on console and then run outside and actually watch the launch, which was great, and hear those sonic booms when the booster came back. Our launch teams have been incredible, but I'm just so thrilled for the SWOT team, who's been, I've only been at JPL for 6 months. The SWOT team's been working on this for so many years, and thrilled for an exciting mission to come. Of course, we still need that acquisition of signal. We're not getting ahead of ourselves, but so happy that my first launch is an Earth science launch, because this is the planet we care the most about.
Fantastic. While JPL is known for operating deep space missions, how much of JPL's work is devoted to studying Earth?
It's more than people think, right? People know us for cool Mars rovers and helicopters and for orbiting Jupiter and these and wonderful telescopes that look into deep space. And of course we do all of that. But in fact, with the launch of SWOT, we now have 15 Earth science missions currently operating, either dedicated missions or big instruments on other missions. So we've got a lot of eyes on Earth at JPL. And the thing about them is, whenever we do something at JPL, we want it to be technologically advanced. So we're always the ones trying to really push the boundaries of what's possible, and that's really what SWOT's going to do. It's a whole new way of measuring Earth's water, and we always want to be pushing the boundaries of innovation. With all those 15 missions, now we've got about 7 more that we're working on that we'll be launching in the next few years. So a lot more Earth science work ahead of us.
So what are those next 7 missions that you mentioned, Lori? What's in the pipeline?
Yeah, so there's 4 of them are going to launch in the next couple of years. So the first 3 are are fairly small, actually, small missions that have kind of focused objectives, but really important things like looking at aerosols, particles in the air, working with actually local medical professionals in cities to try and understand the impact of aerosols on health. What a really interesting idea, right? We have a mission that's going to be looking at the heat at the poles of the Earth to try and understand better sort of the thermal environment there, so that as we the poles really help drive circulation and climate change, and so understanding that environment is really, really important. And the third one is actually going to work on methane super emitters, one of the most powerful greenhouse gases. We're going to be detecting it with greater sensitivity than ever from space, so that we can actually mitigate methane emissions, which is super exciting. So those are all three kind of small ones. But the next really big Earth science mission, sort of on the scale of SWOT, is a mission called NISAR, which is a collaboration, NASA's first major collaboration with the Indian Space Agency. So exciting. And if SWOT is focused on water, NISAR is focused on land. It's really going to be a mission that's going to teach us help us sense and detect changes in land that are affiliated with things like earthquakes and volcanoes. Oh, I so wish it was up there right now as Mauna Loa is erupting. But it's going to help us see those things better from space. It's going to help us understand vegetation all across the land and many, many other applications that are going to be so valuable to folks. So we've got the water covered with SWOT, and we'll have the land covered with NISAR.
Gloria, that sounds like so many great missions ahead. Yes. Thank you so much for joining us today. When LSP selects a rocket for a mission, they have to take into account just how hot it gets. Jasmine spoke with a thermal engineer about protecting the precious cargo.
Joining us now is Dave Purick. He is the lead thermal engineer from the Launch Services Program for the SWOT mission. Thank you so much for being here, Dave.
Well, thank you for having me. It's a pleasure being here and talking a little bit about what we've been doing from SWOT from the thermal perspective.
Awesome, very exciting. So you focus on integrated thermal analysis, a big term. Can you break that down for us?
Absolutely. So an integrated thermal analysis is just like it sounds. You're integrating different entities, and in this case, we're integrating a second stage launch vehicle model and a unique spacecraft along with the interface that connects the two, like your payload adapters and your isolation systems, and seeing how they interact with each other and making sure that one doesn't adversely affect the other.
Right, so you're really kind of protecting the spacecraft from the rocket and vice versa.
Absolutely. And so as part of an integrated thermal analysis, we're really running mathematical models to make temperature predictions on launch vehicles and spacecrafts. And so what that entails is, as a thermal engineer, you're really worried about three different modes of heat transfer: radiation, conduction, and convection. So convection is, think of when you're outside and the wind is blowing, that's convection. So radiation, it's like the sun beating down on you, solar radiation. And then conduction is kind of like taking a coat hanger, unraveling it, holding a lighter up to one end, and then the heat will transverse down through that little coat hanger, and that's conduction through materials.
Right, a really good explanation of something complex there. I understand there's different challenges that could happen along the way too. Can you tell us what was unique or challenging about working on the SWOT mission?
Yeah, so when we're doing any of these assessments, the three main modes of heat transfer that I just mentioned, well, once you're in the vacuum of space, one of them goes away because you no longer have convection. You're in vacuum, and so for SWOT in particularly, we had to face some modeling conversion challenges. We are working with our European counterparts in CNES and Thales, and they threw us a curveball pretty early on, and we didn't necessarily know what one of their software packages were, so we used a lot of really good teamwork and collaboration throughout the agency, and not just Kennedy Space Center and JPL, but we leveraged our resources up at Goddard Space Flight Center, who has done some of these conversions before. And that's just the type of community and teamwork that our niche little area of analysis has grown over the years.
Dave Purick, thank you so much for joining us.
Well, thank you for having me. I appreciate it.
Absolutely. Back to you.
We are nearing spacecraft separation. Let's go back to our commentators, Megan and Denton.
Yeah, we're about 51 minutes after launch, and now we are awaiting spacecraft separation. So SWOT, the spacecraft separating from Falcon 9's second stage.
Yes, and that'll occur as we get closer to the Hartebeestad ground station. And now we see a good video there of the SWOT spacecraft looking up, and then there's another cycling through of the MVAC engine. So yeah, once we get to the point where we separation occur, hopefully we'll get a good video of that. And now there's a slight chance we may get acquisition of signal from the spacecraft at that point in time, but that's not the primary opportunity to get it.
Sure. So you see the telemetry data right there, stage 2, just at the tip of South Africa. You were mentioning a ground station there.
Mm-hmm.
It's because when the spacecraft separates from the Falcon 9 second stage, we want to make sure we know where it is,
Yes.
and we do that by using the ground station,
Correct.
right?
Yeah, and the ground station is what is capturing the video that you're seeing here, as well as the telemetry coming from the vehicle. So that's how the team down on the ground is able to see everything in the, that's happening in the data and actually get the video as well.
So you see the SWOT spacecraft there. SWOT stands for Surface Water and Ocean Topography, and is a joint mission by NASA and CNES, France's space agency. They had contributions from both the Canadian and UK space agencies.
Yep, and once separation occurs...
SWOT payload, separation confirmed.
There you go.
And we got good video.
And we're hearing some cheering here at the Mission Directors Center at Vandenberg Space Force Base. I'm sure the spacecraft team for CNES is also cheering in their Mission Control Center. You see the spacecraft floating away right now from the second stage.
And at this point, the launch vehicle's job is done. So the second stage will just basically kind of back off, move away from the spacecraft, and kind of take itself out of orbit, just so we don't have any junk floating around after it's completed this mission.
Now, it's just so great to see all this
Yes.
live video. I'm still just watching it amazed, just to see it. And this is a moment that so many people have been waiting for,
Yeah,
right?
absolutely. As we mentioned before, a lot of these people have been working this mission for 20 years.
Right.
And now we getting a good view of, you can kind of see the sun there. From the view of the second stage, looking at SWOT floating away, and you kind of see the sun coming into view there. It's an awesome sight to see.
Now, as a member of NASA's Launch Services Program, Denton, how does it feel to be part of a program that facilitates so much great science like SWOT?
I mean, it's always exciting to see that, we kind of play a role in helping enable a lot of the science that these spacecrafts provide for us, and that, help us in our daily lives. And it's kind of, and sitting here on console is kind of, it's exciting and nervousness at the same time. You're excited that, you're getting to this point in the mission, and you actually get to see this launch and to see the spacecraft go on its journey. And it's nervous at the same time because you want to make sure everything goes right. And
Sure.
the team and the engineering team has done a tremendous job of making sure that this mission has been successful.
And so we were saying again, the next step, right, is the team confirming a signal with the spacecraft. Oh, here,
Yes.
This is a shot of the CNES team. Again, this is a joint mission between NASA and CNES, France's space agency. So I'm sure everyone there was cheering the same that they were here at the Mission Director Center once we saw the spacecraft float away.
Yeah, and hopefully we'll hear from the team in France that they've acquired signal from the spacecraft, and we'll be looking to hear that coming up soon, hopefully soon.
Yeah, the first full pass for signal is slated for T plus 1 hour and 18 minutes. You did mention that we might get some initial data around this time, but really what the team is marching towards is that 1 hour, 18 minutes. That's when we really want to confirm signal, meaning that the spacecraft is healthy and it's where we want it to be.
Yeah, and that's an important step in this whole process. Is after the ride, it's kind of like you ride on a roller coaster, and you want to make sure after you get off, you got all your belongings, everything's looking good, and that's essentially what it is. Where we waiting to kind of hear confirmation that the team in France is able to communicate to the satellite, make sure everything's good, and everything went well with the ride.
Okay, so we got a couple of minutes to wait for that acquisition of signal. So until then, we'll send it back to Raquel and Nadia.
Thank you, Megan and Denton. We have some more questions to get to. The first is from a student who has a question, and her name is Micaela.
Hello, my name is Micaela. And I have two questions for you today. One is, how long will this mission take? And number two is, what is the range of accuracy with this technology? Thank you.
Some great questions there.
Yes, Michaela looks like a future engineer with a very smart question. So, Michaela, the prime mission timeline is 3 years. And our targeted accuracy for ocean heights is about a centimeter accuracy for smaller features, less than 1,000 kilometers. And for larger features, which we're going to use our other non-carrying altimeter, we're shooting about 3 centimeter accuracy and about 10 centimeters for inland waters. So great questions, Michaela.
Yes, an engineering career in her future. Yep. We also have some more social media questions to get to. Let's take a look at the first one. When will SWOT data be publicly released?
We'd have a first look at the data about nominally fall 2023. This is where we are inviting our science community, Raquel, to help NASA to validate and take a first look at the data. We call it a pre-validated data sets. So don't write your Nature papers yet.
Okay.
But fully validated data I expect it to be around the spring timeframe 2024.
Okay. And we have another question coming in here on social media. Alessandra asks, what will be the probe's data processing centers?
So the major processing data would be our French partners, and then data would be downlinked to JPL and back. So this is, again, a team effort.
Yeah, showing off that international collaboration.
Exactly.
Let's get to our next social media question. Will it measure ocean depths at what resolution?
Ocean depth, we're actually, I have a few scientists on the science team who are looking at the seamounts and bathymetry using SWOT, and they are also excited to see and discover thousands of new mountains on the bottom of our oceans. So yes.
Let's get to the next question. Is there more water in the atmosphere of Earth than there is on all the surface of oceans on Earth? What amount if subterranean water is unknown currently? They're really asking you tough questions.
Yes, and I think maybe they just was excited with our demonstration. So most of the water is, of course, located in the ocean. We just saw it in this hour gallon. And the only tiny portion of the Earth global water cycle is contained by the atmosphere. So atmosphere cannot hold a lot of moisture, and but it's very effective at transporting water between the ocean and land.
Great, thank you, Nadia. Now, if you have a question to ask, post your question online with the hashtag #TrackingWorldWater. You did a great job answering those. SWOT will create the first comprehensive global survey of freshwater lakes, rivers, and reservoirs from space. Let's go to Jasmine live at the Hawk's Nest, who is with a scientist eager to use the new data.
Thanks, Raquel. Yes, joining me now is Tamlin Pavelski, the SWOT Hydrology Science Lead. Thank you for being here.
Oh, my pleasure.
We are so excited, especially after seeing that spectacular launch, Tamlin. And right now, scientists really have to trek into the field to understand the data from rivers and lakes. Tell me, how is SWOT going to change that?
Oh my gosh, it's going to change it so much. So, right now, if I go into the field for a field campaign, I might be able to go and measure a couple of rivers, a few dozen lakes. SWOT is going to be able to see lakes all over the world in places I can't even get to, where it's just impossible. And so the kind of science that we're going to be able to do with SWOT is just orders of magnitude above what we can do with just data on the ground. That said, even more powerful is going to be combining the kinds of measurements we can make on the ground with the groundbreaking measurements we'll make with SWOT.
Exactly. So we're combining kind of the methods that we've already used with some new things from
Exactly.
SWOT. That is so exciting. And what are you most excited? What measurements are you most looking forward to from SWOT?
So I think I might be most looking forward to SWOT's measurements of lakes. So we're going to be able to measure simultaneously the water level in lakes and the area of lakes. We'll be able to see changes in volume. And we're not just going to be able to see that in a few lakes, right? Right now, maybe we can see a few tens of thousands of lakes using on-the-ground data. With SWOT, we're going to see millions. So it's like going to a more powerful telescope where suddenly all these new stars appear.
Right. And when you say that figure millions, I mean, that's so hard to even picture, but it's really, really exciting. And how is SWOT going to help us understand how water moves worldwide? I mean, this is a global view.
Yeah, so I think a lot of us start learning about the water cycle really early on, in elementary school or middle school maybe. And, that's because it's so fundamental to how our planet works, and water is a precious resource for us. And SWOT is going to tell us about one of the most critical parts of the water cycle, which is surface water, right? So we have evaporation, right, off of the ocean and off the land. We have precipitation coming down. SWOT is going to help us put real numbers on how the amount of water flowing through rivers is changing over time and how climate change is affecting that.
Right. That is so exciting to see how this is all working together. Tamlin, thank you so much for being here.
Oh, my pleasure.
Awesome. Raquel, back to you.
Thank you. SWOT is going to measure how much water is on Earth, but also how it moves. We actually don't know the extent of some of the science that this is going to produce.
That's
and
right.
I'd like to introduce you to Christine Gabarra. She's a mechanical engineer inspiring future generations.
Coming to work every day, it's always really nice to know that the system that we're building will collect science data that will be spread publicly, that the data will help people. Hi, my name is Christine Gabarra, and I'm an integration test engineer at JPL. SWOT is an Earth orbiting satellite. It stands for Surface Water Ocean Topography, and it'll give us more accurate data on how the water levels, the freshwater and the saltwater levels, are changing with time. The day-to-day varies a lot. We're usually either setting up for a test, testing, breaking down from a test, or moving the spacecraft. The coolest parts of SWOT to me are the engineering bits that are slightly extreme. So I've really enjoyed working on the deployable antennas. It's nerve-wracking, but it's a well-rehearsed dance. And when the antennas actually deploy, they're really beautiful. They're moving slowly and intentionally, like a butterfly. I grew up in Houston, Texas. I was very lucky to be part of the Girl Scout sailing program, where they taught us not only how to sail, but they taught us the very basics of aerodynamics and how the sailboat worked. I became an aerospace engineer because of that program. The ability to say, oh, I know how this works, and then going to implement it in a way that was fun and exciting was really rewarding. If I were to tell a little girl how to get into engineering, I would tell her just to get started in whatever way feels exciting and natural. It gets a lot easier once you just get started and start tinkering with things and building whatever excites you. It's not lost on me at all that I grew up sailing and I still love the water, and the spacecraft that we're building will help us track our oceans and our lakes and our rivers. Hopefully we'll be able to sail for much, much longer in beautiful blue waters.
SWOT is a joint mission between NASA and CNES with contributions from the Canadian and UK space agencies. Joining us now is Caroline Laurent, the Director of Orbital Systems and Applications at CNES. Thank you for joining us today.
Hi everybody.
Hi, Caroline. What does it mean to finally see this satellite in space?
Well, it's so great. It's such an experience. What I'd like to say is I'm so proud of everybody. I'm proud of the French teams, of course, of my teams from CNES and Thales Alenia Space, but I'm also so proud of our collaboration. And of course, this success is due to our common teams and to NASA, JPL, and SpaceX. I want to congratulate everybody for this incredible launch. And I'd like to say I'm really proud to see what international cooperation can achieve together for the common good. So it's a great day.
Yes, and there's lots of activity still happening here at Vandenberg Space Force Base. What is happening over at CNES in the main control center at France right at this moment?
Okay, so in Toulouse we have the main control center, and we have ground stations all over the world. So first, the satellite has an autonomous maneuver for an hour and a half, and we'll have the solar panels, which is the main important thing happening, which will be deployed. But then they will take fully control of the satellite in 1 hour and a half, probably from Sweden or South Africa. And during that hour and a half, although the satellite is on an automatic mission, it will send information so the people can start having them. And so there are people that will be 24 hours a day working, starting from now through Christmas, and everybody. I want to congratulate them, of course.
Mm-hmm.
And then they will start deploying the antennas in a few days. And once it's fully in orbit, they will start switching on the payload and start receiving. Then the calibration and validation will start, and then they will start receiving all the data, and they will in the end get 8 terabits of data everywhere. Every day that will be that will flow down through all the over the world stations. And that's it. But right now they're all ready to get the first pings of the satellite and send the first orders within an hour.
Thanks, Caroline. So as we start a new altimetry era with SWOT, when you reflect back, what do you think of SWOT as building on a legacy of NASA and CNES altimetry friendship? Can you comment on that?
Yes, it's been an incredible journey, starting more than 40 years ago. And I'd say the main event was the launch of TOPEX Poseidon in the summer of 1992, which was the first altimetric mission. Then there were all the JASON's missions. And of course, SWOT is a breakthrough because now we're going to monitor water. And before that, we were only surveying the oceans. So that's a major breakthrough, and that to monitor globally all over the world the water is really important for our world for the next decades. And as I said at the beginning, I mean, it's an incredible collaboration. We have also Canadian and British friends working with us together. And it's good to see what we can achieve together. And it's such an incredible collaboration. So right now, I'm expecting us to exploit SWOT and to have a lot of years of tremendous data with SWOT. But I'd like to think already of future missions that we could build together, because it's been a great collaboration.
Thank you, Caroline.
Caroline,
Yes.
thank you for joining us. Well, the SWOT satellite can see rivers that are wider than 330 feet. That's about the length of a soccer field. Cedric David, a hydrologist who studies the world's rivers, shared his unique connection to water.
There is something about the environment that's just incredibly cool. A lot of what we do as scientists is we're just curious. And so anybody who's a curious person ought to be a scientist, in my opinion. You can think of the world's rivers as Earth's arteries because they're essential to life. I'm Cedric David, and I study the world's rivers. SWOT is a mission that is specifically designed in part to observe rivers, and it's also being designed jointly by NASA and the French Space Agency. I was born in France, but I've lived in the US for 18 years now, and I study rivers. So SWOT is a little bit of a match made in heaven for me. The kind of science that I'm interested in is trying to understand how much water flows down the rivers of the world, and SWOT will be able to make one such measurement for all of the largest rivers of the world. So we'll be able to get a global, unified picture of surface waters from space. This in itself will be a scientific revolution. I think that's going to have a big impact on water management. I like to say that water is my friend. Water is my happy place. I was born with a physical disability that affected both of my legs. Being able to walk now was not a done deal at birth, and it still involves a significant amount of discomfort and is a constant reminder of having been born different. For as long as I can remember, water has been the only place where I felt comfortable, where I felt normal, where I felt like I could do things like everybody else. When I get in the water, it's just like, I mean, you're floating. When you're floating, it's just like all the pain goes away. As a kid, my parents would take my brother and I all the time to jump in the Mediterranean. But to this day, we still do it on New Year's Day every year. Planning for future generations requires us understanding how much water we have And SWOT will be able to provide that global view of the world's freshwaters. And in my opinion, it might very well become the key that unlocks surface water observations around the world and unleashes surface water management. So it might help us make sure that everybody gets access to fresh water. Now more than ever, it's important to recognize that water connects us all, and it might be the one thing that unites us all.
We have some more questions to answer, and before we get to the social media questions, we have one from Easton.
Hello, my name is Easton. I'm 6 years old and I'm from Wayne, Indiana. And I have a question for you. Can you see SWOT from our planet?
That's a good question, Easton. Well, SWOT is relatively small compared to other celestial bodies, and it's not as bright as, say, moon. It's about 500 miles above the Earth's surface. But maybe with a pair of good binoculars, far away from major cities on a particularly night sky, you can spot SWOT from Indiana, where you live.
Invest in some binoculars there. We also have social media questions coming in, so let's get to the first one. Let's see, Elaine, will SWOT measure ice fields, glaciers, and snowpack, or just liquid water?
So the primary focus for SWOT is ice-free water, but we do have a couple of scientists who are interested to use SWOT measurements for the height of sea